underneath Yellowstone that if it erupts in a maximum eruption called Category 8, it could literally tear the guts out of the United States of America.
Yellowstone's supervolcano is no small thing. We're talking about global impact. Let's dive into what Kaku's recent discovery means for 2024 and why we should all pay attention. The science behind Yellowstone. Yellowstone National Park, straddling Wyoming, Montana, and Idaho, houses one of the most intriguing and active volcanic systems in the world. At its heart lies the Yellowstone supervolcano, a colossal volcanic structure and a profound impact on Earth's geology. The supervolcano is essentially a large caldera, a type of volcanic crater formed by the collapse of land following a major volcanic eruption. The Yellowstone caldera, one of the largest on Earth, measures about 30 miles, 48 kilometers across. This immense structure was created by a series of volcanic events, with the initial caldera formation occurring approximately 2.1 million years ago. This was the result of the Huckleberry Ridge eruption, which expelled enormous amounts of volcanic material, leading to the caldera's formation. The region's geological history is marked by several significant super eruptions. The most recent major eruption occurred around 640,000 years ago, further shaping the caldera and contributing to the park's distinctive geothermal features. These eruptions released vast quantities of ash and volcanic gases, affecting global climate patterns and altering ecosystems across North America. The underlying cause of Yellowstone's volcanic activity is a hotspot, a stationary region of intense heat in the Earth's mantle. This hotspot causes the melting of mantle rock, leading to the rise of magma toward the surface. The interaction between this magma and the Earth's crust results in the geothermal and volcanic activity observed in the park. The hotspot remains stationary relative to the moving tectonic plates, which has caused a series of volcanic activities across the region over millions of years. Yellowstone's volcanic activity is characterized by its cyclical nature. Unlike typical volcanoes which can erupt relatively frequently, supervolcanoes like Yellowstone have long periods of dormancy between major eruptions. These cycles involve phases of increased volcanic activity followed by long periods of relative quiet. During the dormant periods, magma accumulates beneath the caldera, building pressures within the magma chamber. This pressure can eventually lead to explosive eruptions when it reaches a critical point. The supervolcano's unique nature means that it can produce extraordinarily large eruptions with global implications. For example, the Huckleberry Ridge eruption approximately 2.1 million years ago was one of the largest eruptions in the past 2 million years, releasing an estimated 2,500 cubic kilometers, 600 cubic miles of volcanic material. This eruption had far-reaching effects on the environment and climate, with ash deposits found across much of North America. Yellowstone's volcanic system is also marked by its geothermal features, such as geysers, hot springs, and fumaroles. These features are manifestations of the heat generated by the underlying hotspot and provide additional insights into the volcanic processes at work. The park's geothermal activity is a result of the interaction between magma and groundwater, which produces the high-temperature features observed today. Given the potential hazards associated with Yellowstone's volcanic activity, scientists employ a range of monitoring techniques to track changes and assess risks. This monitoring is crucial for understanding the current state of the volcanic system and providing early warnings of potential eruptions. Ground deformation is a key focus of monitoring efforts. Instruments like GPS stations and satellite-based radar systems measure changes in the Earth's surface, detecting any swelling or subsidence of the caldera. These measurements can indicate the movement of magma beneath the surface and help scientists assess whether increased volcanic activity is occurring. Seismic monitoring is another critical aspect. Seismographs are used to detect and record earthquakes, which are often linked to volcanic processes. By analyzing earthquake patterns, scientists can gain insights into the dynamics of the magma chamber and the likelihood of an eruption. Earthquake activity can reveal shifts in the magma reservoir or the fracturing of rocks within the caldera. Thermal imaging plays a role in monitoring surface temperature changes. Increased heat flow can indicate changes in geothermal activity and provide clues about underlying volcanic processes. Thermal sensors and infrared cameras are used to measure temperature variations, which can help identify areas of heightened volcanic activity. Gas monitoring is also essential for understanding volcanic processes. Instruments detect and analyze volcanic gases such as sulfur dioxide, carbon dioxide, and hydrogen sulfide. Changes in the composition and concentration of these gases can provide valuable information about the magma's behavior and potential eruption scenarios. Overall, the combination of ground deformation measurements, seismic activity analysis, thermal imaging, and gas monitoring provides a comprehensive approach to understanding and managing the volcanic risks associated with Yellowstone. Through these advanced techniques, scientists continue to enhance their understanding of the supervolcano's behavior and ensure timely detection of any significant changes in its activity. Michio Kaku's discovery. Michio Kaku is a famous person in both theoretical physics and popular science. He's known for making important contributions to both fields and for making difficult scientific ideas interesting to understand. Kaku was born on January 24, 1947, and has become a well-known theoretical physicist and science advocate. He has made a lot of progress in string theory, quantum mechanics, and astrophysics. He's a professor of theoretical physics at the City College of New York. Kaku is admired for both his groundbreaking research and his unique ability to explain complicated science ideas in simple terms that everyone can understand. His books like Physics of the Future and The Future of the Mind and his many TV and radio appearances have made him a well-known name in the field of science communication. Kaku is well known and respected for being able to make difficult topics easy to understand. Michio Kaku recently got a lot of attention for a big finding he made about Yellowstone National Park. This park is famous for its geothermal activity and the supervolcano that lies below it. Scientists have been interested in Yellowstone for a long time because of its unique geological features. Kaku's new results add a big new layer to what we know about this changing system. Kaku's study is mostly about finding new information about how the Yellowstone supervolcano works and what it might do in the future. In the past, scientists have kept an eye on this supervolcano in a number of different ways, such as by taking earthquake readings, analyzing ground deformation, and using thermal imaging. Kaku has come up with a new way to do things by using theoretical physics and complex data modeling to improve on current methods. One of Kaku's most important contributions is a new model that says there's a more complex network of magma chambers below Yellowstone than what was thought before. His research shows that these spaces are linked in ways that could have a big impact on volcanic activity, which goes against the simpler models that were common before. With this new point of view, estimates and risk assessments about possible eruptions may need to be changed. Kaku's team has also used new information from satellite observations and more advanced tools for imaging earthquakes. These new technologies have shown important but subtle changes in ground elevation and heat trends that weren't seen before. By adding these new discoveries to his theory models, Kaku has given us a better picture of how the supervolcano behaves and what might happen if it erupts. Before Kaku's finding, most models of Yellowstone supervolcano were based on looking at things on the surface and measuring earthquakes and geothermal activity directly. Scientists had found a large magma pool below the surface, but they didn't really understand how big and complicated it was. In earlier ideas, the central magma reservoir was usually shown quite simply. Kaku's new model challenges this earlier simplicity by suggesting a network of magma chambers that are all linked to each other. This new model suggests that the movement of magma beneath Yellowstone is much more complicated than was thought before. It also suggests that the way these chambers interact with each other could have a big impact on volcanic events. Earlier study, which mostly looked at a single isolated magma chamber, has changed a lot because of this. Kaku's use of advanced data modeling and satellite observations is also different from older methods that relied more on readings taken on the ground. By using these cutting-edge technologies and theoretical methods, Kaku has given us a new way to look at the supervolcano's behavior that helps us understand it better. Scientific significance. The significance of Kaku's discovery extends deeply into both scientific research and public safety. By uncovering a more detailed picture of the network of magma chambers beneath Yellowstone, Kaku's work improves our ability to predict volcanic activity and assess associated risks. This discovery enriches our understanding of volcanic systems and showcases the potential for theoretical models to offer new insights into complex geological processes. Kaku's research demonstrates how integrating diverse scientific approaches from theoretical physics to advanced observational techniques can significantly advance our knowledge of Earth's dynamics. Moreover, Kaku's work underscores the value of innovative thinking and interdisciplinary collaboration in addressing some of the most complex questions about our planet. His findings not only contribute to the scientific field but also have important implications for public safety and disaster preparedness. Implications of the discovery. The recent finding of more activity at Yellowstone supervolcano has caused a lot of worry because it could have huge effects on the climate, ecosystems, and people around the world. Yellowstone is one of the world's biggest supervolcanoes. It's found under Wyoming, Montana, and Idaho. It has had many huge eruptions that have changed the Earth's climate and landscapes. This new finding could have very bad effects, and to understand these risks, we need to look more closely at the possible effects, how to be ready for them, and how the public and scientists are reacting to them. There are a lot of different risks that could come from an explosion in Yellowstone. A supervolcanic eruption on this scale could cause a world climate event like those that happened in the past. For example, the year without a summer in 1816 was caused by the eruption of Mount Tambora in 1815, which was not as big as Yellowstone. Widespread crop failures and food shortages were caused by this event, which shows how volcanic eruptions can have a big effect on the weather. A similar eruption at Yellowstone could send huge amounts of ash and sulfur dioxide into the air, which would cause a volcanic winter. This would cause global temperatures to drop by a large amount, mess up weather trends, and hurt farming all over the world. The resulting cooling could shorten growth seasons and lower crop yields, which could cause famine and food shortages around the world. The area right around Yellowstone would be hit by terrible disasters. A lot of land would probably be destroyed by the eruption, which would destroy forests and habitats. The eruption's ash would kill all the plants, which would destroy food chains and habitats. The effects on local plants and animals would be terrible, leading to mass extinctions and long-lasting changes in the balance of nature. Long-term recovery of these environments would be hard, and it's possible that this could have ripple effects on biodiversity around the world. The effects would be just as bad for human groups. Cities and towns could be buried under thick layers of ash from the eruption, which would destroy infrastructure and make the places unlivable. There are big risks to your health from breathing in volcanic ash, which could cause breathing problems and other health issues. Besides these clear health concerns, an eruption would have huge effects on the economy as well. The destruction of farming, shipping, and industry would have a big effect on the economy as a whole. The size of the disaster would make long-term recovery harder because it would take a lot of time and money to rebuild towns and economies that were damaged. Because of these possible risks, getting ready for an eruption of Yellowstone is very important. Using a network of seismographs, GPS stations, and gas monitors to look for signs of more activity, the Yellowstone Volcano Observatory, YVO, is one of the best places to keep an eye on the supervolcano. This extensive tracking system is run by the U.S. Geological Survey, USGS, to find early warning signs of possible eruptions. This constant observation is necessary to understand how the supervolcano acts and send out timely warnings to lower the dangers of an explosion. The areas around Yellowstone have emergency reaction plans in place, with a focus on how to evacuate and keep people safe. These plans are meant to handle what happens right after an eruption, such as getting people out of the affected places and providing emergency services. The government is also working on making and improving plans for dealing with the long-term effects of a supervolcano explosion, like fixing damaged infrastructure and helping the community recover. Scientists have come up with a number of suggestions to improve reaction and preparation. They want more money to be put into technologies and studies that keep an eye on volcanoes and help predict eruptions better. Understanding the exact processes behind supervolcano eruptions and making accurate models are important for being ready. Public education efforts are also important to make sure that people in the area are aware of the risks and know what to do in case of an eruption. Federal, state, and local governments need to work together to make sure that resources are used well and that comprehensive emergency reaction plans are made. When scientists and the public learned that Yellowstone was active more than usual, they had a range of responses. People's reactions have ranged from worry and interest to fear and guesswork. The news has sparked a lot of excitement, and many people are looking for more information and talking about what an eruption might mean. Online forums and social media sites have become places where people share safety tips and talk about their fears about what might happen during an eruption. There has been more research and debate in the scientific world since the discovery. To get a better idea of the risks, researchers are focusing on looking at the new information and making explosion models better. The science community is also talking about how to best share the results with the public and handle the risks that come with them. A lot of attention is paid to the need to keep an eye on volcanoes and put money into monitoring them to make sure that correct information is available and that good plans for how to respond are in place. Media coverage has profoundly influenced public opinion on the finding. There's everything from in-depth science analysis to terrifying disaster headlines. Some news channels provide useful information and expert opinions, but others overstate hazards or provoke unnecessary worry. People should acquire their news from reliable sources and distinguish between scientific and speculative comments. Responsible journalism and factual reporting help the public make informed decisions. New research, better technology, and cross-disciplinary collaboration change risk management and understanding. We must examine existing studies, technological breakthroughs, scientific collaborations, and future predictions to understand how future changes will affect risk management. Environmental, health, and technology hazards are being better understood. Enhancing risk assessment models is crucial. Scientists are developing sharper statistical models and simulations to analyze massive datasets. These models provide a more complete risk picture by including additional parameters. Climate specialists utilize these advanced models to predict catastrophic weather events by considering rising sea levels, atmospheric conditions, and regional climate patterns. High-resolution satellite photos and drones are altering environmental science risk monitoring. These programs provide detailed, real-time information on natural disasters, tree cutting, and climate change. This data simplifies environmental risk assessment and management in prediction models. Wearable tech and mobile health apps allow doctors to constantly monitor vital signs and other health data, altering risk management in healthcare. This real-time data helps diagnose heart disease and diabetes early and start therapy. Technological innovations. The progress of technology is very important for dealing with and lowering risks. The use of artificial intelligence, AI, and machine learning in risk assessment is an important new development. AI algorithms are very good at looking at large datasets, finding trends, and predicting possible risks. For example, AI-driven models are being used to improve systems that send out early warnings about natural disasters like storms and earthquakes. A lot of seismic and weather data can be processed by these systems to send out timely alerts that could save lives and limit harm. Improvements in technology are also having a big effect on safety. Cyber threats are getting smarter, so more advanced security measures like behavioral analytics and threat intelligence tools have been made. By looking at trends of behavior and finding outliers that may point to a breach, these technologies help businesses find and stop cyber attacks more quickly. Also, progress in science is making it easier to understand and deal with health risks in new ways. Genetic and genomic research is giving us new information about how people are likely to get different illnesses. With this information, customized medicine can be created, in which a person's genetic profile guides their treatments and preventative measures. These kinds of innovations could lead to better and more targeted ways of controlling health risks, which could lower the number of diseases and their severity. Taking on risks that are complicated and have many aspects often requires scientists from different fields and places to work together. Scientists are realizing that they need different kinds of knowledge and points of view, so interdisciplinary research is becoming more popular. To fight climate change, for example, environmental scientists, economists, engineers, and politicians all need to work together. Taking a look at climate change from different fields of study helps make plans that cover both the scientific and economic parts of the problem. For study and innovation to move forward, institutions must also work together. Groups of universities, research centers, and private businesses are working together to do big studies and create new products. These partnerships make it easier for people to share resources, data, and knowledge, which speeds up the process of finding and use. For example, working together on genetics research has led to big steps forward in understanding genetic diseases and creating new ways to treat them. To deal with global risks that go beyond national lines, countries must work together. Groups like the Intergovernmental Panel on Climate Change, IPCC, and the World Health Organization, WHO, are very important for getting people all over the world to work together. These groups make it possible for people to share information, work together on study projects, and carry out international agreements. As an example, the Paris Agreement on climate change is a promise by all countries to cut down on greenhouse gas pollution and lessen the effects of climate change. These kinds of global activities are necessary to reach common goals and deal with global risks. Looking ahead. As we look ahead, a number of important areas are likely to change how we understand and deal with problems. The continued progress of AI and machine learning is one of the most exciting things that could happen. People think that these technologies will change the way risk is evaluated and managed by making predictions and plans more accurate and tailored to each person. Early warning systems for natural disasters, health problems, and cyber threats could be improved by AI-driven models. This would allow for faster and more effective reactions. Also, we may learn more about genetic and epigenetic factors that affect the chance of getting diseases and being exposed to environmental risks in the future. Personalized medicine and preventative care could make big steps forward with the help of ongoing study in these areas. By learning how genetic and environmental factors affect each other, we might be able to create targeted treatments that deal with each person's unique risk profile. Furthermore, progress in technology is likely to lead to fresh ways of handling risks. For instance, using blockchain technology in supply chain management could make things more open and safe, lowering the risk of theft and making it easier to track things. In the same way, new developments in green energy and environmentally friendly methods could lead to better ways to protect the environment and deal with climate change. There will likely be changes in how we manage risks as our knowledge of them grows. It's possible that new discoveries and inventions will lead to better and more nuanced ways to deal with both old and new problems. You can't say enough good things about ongoing study, teamwork, and technological progress. They're necessary to make our future safer and more resilient and just help us better handle risks. As we brace for the unknown, Michio Kaku's insights remind us of nature's power. Stay informed and prepared. Click the video on your screen for more details and don't forget to like and subscribe for the latest updates.